object-oriented programming polymorphism. So far we have noted this syntax where we have this name equals name, so we are getting, for example, constructor gets parameters and they are set to the member variables. And every object has a reference, this that references the object itself. It's very logical that this means this object itself. So this reference is always the same type as the object, like it was defined my class this. So we would have a variable pointing to that object itself. And we have used this keyword when we have set parameters and also when we are returning this from a setter method, so then we can chain those set methods. But there is more. So polymorphism part 1. Polymorphism in object-oriented programming means that the type of the object and its methods are chosen during runtime. So for example, if we have an array list full of different types of animals, cats, dogs, giraffes, hedgehogs, lions, and if they all inherit from superclass animal, we can iterate through the list, for example, like this. You have a for each loop which goes through this animals array list, and then we take just one animal out of the list in a time and let it speak with this speak method. And we cannot specifically say which animal is speaking from the code. It's just some animal is speaking, but Java will then figure it out which animal, if it's a cat, if it's dog or hedgehog or whatever. We cannot tell it by just reading the code. Another way to understand polymorphism is that the object can be of any type that it inherits from. For example, student can be human, mammal, animal, or starship can be rocket, or hedgehog can be mammal, these kind of things. So we can use those superclasses when we are building, for example, array list. Polymorphism part 2. So single action is performed in different ways based on what is the actual object in the variable. So here in the right we have a starship object that is saved or created in rocket reference. That is completely fine because starship is a rocket and then it can launch, so we can set rocket launch. It will work. The rocket will launch because the rocket class has this launch method, but it cannot land. So rocket land will not work because the rocket class doesn't have this landing method, but starship has. But we can fix the issue by casting the rocket reference to starship, then it's starship and then it can land. But if we try to, for example, cast Saturn V to starship, that is not true because Saturn V is not starship. Saturn V is a rocket and starship is a rocket, but Saturn V is not starship. That will crash that kind of code. So Java will automatically call the correct implementation of a method that exists. For example, this launch method. It will call the starship's launch method, and if there is no starship, there is no launch method in starship, then it will call the rocket's launch method. But there is only those methods are available that exist in a superclass. So that's why the landing method won't work. And if we want to use the subclass method from the reference that is pointing that is type of a superclass, then we need to do the casting. So let's have an example on this one.
So we have our application here, and let's build places for these rockets. So first of all, we need few classes. We need ISS, International Space Station, and then we can have this Starbase class. And ISS and Starbase, they can both have rockets, so they are similar in that sense that they are places for rockets. So we can have a superclass for them. Let's call it a rocket garden. So these ISS and Starbase are extending that rocket garden. Like this. So now we have two classes that should have rockets, so we can go with this class. We have the super class, which holds all the information, and then we have the subclasses that can have extra information and methods. But let's go with this rocket garden. So this is wrong. Let's try to change it to rocket garden. Yes, now it's okay. NetBeans isn't that clever. And this should be rocket garden, of course. Like that. Okay, so the rocket garden needs to have some kind of data structure to store all these rockets. So we will need an array list which holds rockets. And this is just a general rocket, not a Starship or a Long March 9 or Saturn V, just a rocket. And it's new array list. And we do not want this array list to be seen from the outside, so anyone just has access to that. That's not what we want. We want to protect it. No, now it's okay. So now this rocket garden can access it, and also the childs, the subclasses ISS and Starbase can access to this array list rockets. We have a constructor, but we are not doing anything there, not yet at least. Then we should have a method to add those rockets. So add rocket, and we are just getting these rockets, and we are adding a rocket there, just like that, nothing else. Then we should have some kind of getter, so we are getting a rocket. And we are first checking that if the rockets is empty, then we cannot return any rocket, so we are checking that if it's not empty, of course. So then we are returning rockets, the first object in this rocket array list. And otherwise we are returning null, there were no rockets. Then let's build a method that can list all the rockets, so it just list rockets. Just a simple method. And we are telling that there are the following rockets. Rockets available. Yeah, and now we should go through the rockets. We can use for loop of course for that. We iterate through this rockets array list with this for each loop, and then we just use the rocket print information method, so it will print all the necessary information from the rocket, and this rocket has had this print information here, so it will print the rocket name and what astronauts and cargo it has. So this is pretty simple, but now in this code we cannot tell which rocket these are. So they are just rockets, but we can put to this rocket array list, we can put their Saturn V, Starship and Long March 9 rockets. And so let's see how this works. So we have built here a few rockets. So let's not, we don't need to print any information. We have built rockets. Let's remove this one. Then we have a Saturn V there. We do not need to launch them. And no interview needed. So we need first to build some kind of a starbase. For example, then we can add to this starbase, we can add rockets, we can add all the, we have created so far 3 rockets, so we have this Starship, Long March 9 and Saturn V. And now this our starbase can list those rockets, so let's try, let's see what happens. So starbase, there are following rockets available, so it's calling correctly this list rockets as we want it. So we built the starbase which extends, we built starbase which extends rocket garden, so we are now using the rocket garden list rocket method here. And then it describes that there is a Starship with the following stuff, then there is this Long March 9, and finally there is a Saturn V that has 2 astronauts. And of course we can set more rockets. So let's add rocket, just new Starship, like that. Now our starbase has more rockets. Let's try it again. And now it's describing that there is a Starship which has nothing inside, there is a second Starship, nothing inside, third and fourth one, and then there is this Starship, Long March 9 and Saturn V that has something inside it. Similarly, we could build a ISS. And put some rockets there. Add rocket. We could technically put the same rocket there. This will go through compiler, yes, but in a physical world we cannot have the same rocket in rocket base and in the starbase and ISS. So I'm removing this Starship, and let's put that Starship on the ISS. And then we can just set ISS list rockets. and now this is listing that what we have in the ISS. So this is how we are using polymorphism. So we are building different objects. Here we are building a starship, Long March 9 and Saturn V, and then we are putting them into a variable which type is rocket. Starship is a rocket, so we can store it here. So in that sense we could actually demonstrate it like this, that we can have a rocket R which is new starship. This is fine. Starship is a rocket, so we can definitely have this kind of a code. And now we just, if we want to have this, we can launch the rocket. Yes, that's fine, but we cannot land it. The starship has this land method, but now we are working with the variable that is rocket, so it's not possible to land it. We need to cast this rocket to actual starship, which is these. No. So now it can land. So we are modifying this rocket reference to starship, and then it can land. Just casting. This casting here is basically a similar thing if we have a int x which is casted from a float 3 point something. Here we are casting a float number to integer, and this here we are casting a rocket to starship. So now if we are running this code, we cannot launch empty rocket, and then starship has landed successfully, even though it did not launch because it was empty. But yeah, this is how the polymorphism works.
And so as a conclusion, polymorphism is one of the cornerstones in object-oriented programming. Besides inheritance and encapsulation, polymorphism is the third thing that is very important in object-oriented programming. And it eases the programmer's work, as she can, for example, put various object types to an array list. When we have inherit a type and we have a superclass, we can use the superclass as a definition and then actually use subclass objects.